We're going to make a video on how I do my continuity test on my circuit here. I mocked up a little lighting circuit, and the reason I want to show you the continuity test, or at least how I'm going to do it, is basically I'm making a video and I want to go back in time and watch this video so I know how I'm going to do my continuity test. Now, I'm not saying you should do your continuity test like this. You do it however you want, however you feel is safe, and you get your advice from wherever. This is just for my entertainment purposes, information purposes, however you want to consider that, okay? So do your research. Now what I have here, this is my little continuity tester. This is just the cheapie, and it's not all fancy like the ones that cost a lot of money, but the only thing continuity is that it's just going to tell you if something will take electricity through it. Like I have a nail right here, so I can take it from one side of the probe to the other side of the probe, and it should tell me that I have continuity. Okay, because look, if I put the two probes together, then it shows that there's continuity, that the electricity will pass through there. So why it's not doing it with the nail? Oh, it did it. See, I just have to push it harder. It's doing it with the nail, but the nail has this little protective coating on it, so that's why it doesn't show continuity so well as if it were like a wire. Okay, so I have this piece of wire right here. Hazte un poco más para atrás. I have the piece of wire right here and it shows the continuity. Okay, so why do I care about a continuity test? Well, I want to make sure that my wire, when I run in my house, I want to make sure that it's going to carry the electricity. So basically, all I'm doing is I'm testing one end of the wire and the other end of the wire, but my probe's only so long. So now let me take the camera from JJ and I'm going to show you my little circuit I mocked up, okay? So if my circuit starts right here and I want to test the black wire and it goes all the way over there on one of those ends, my probe's not long enough to go from here all the way to the other black wire. So what I do for my continuity test is I put the black wire and the white wire together, and that's just making one long wire. And also it's letting me test the black and the white at the same time. And then I can also do the same with the black wire and the ground wire. So what I did right here with this little piece of wire on the end of the plug, I'm basically just connecting the black wire and the white wire. The reason I have this plug here is because after I do the continuity test, I'm going to hook all this stuff up just to the extension cord and test it with my voltage and make sure that I have my 120 volts all the way around the circuit. So let me show you this. Now I've got my black and my white hooked together right here, so now I'm going to go to the end of the run on the circuit right here, and I'm going to take my black and my white and stick my probes on. Well, how comes nothing's happening right now? Well, it's because I'm on the insulation. So I just take it, I open the Wago wire nuts. These are really handy, and I just put this in here. And I put this in here, and I have continuity. So basically I know from, let's follow this right here. I know from right here where they're hooked together, comes through here, and then this is gonna be representing my switch for my lights up there. See that on that run? But then this goes down, and I'm using this to represent, there's going to be an outlet right here and an outlet right here. Now, do I have to test for continuity right here? I could, but I don't have to, because I already know I've got the continuity at the end of the circuit. Well, at least at this end of the circuit. But I'll do it anyway just to show you. So I could take it and I could put it in here, in the white and in the black, and I have the continuity, okay? So that's why I don't really have to test every single one if I don't want to, but it's not gonna hurt everything if I test every single one. Now, let's talk about why I do it like this. Now, if this was in the wall, I would have already knocked these out, and I would have put my wires through there. But I'm not going to knock it out, because then once I knock these out, I can't use this box anymore, because the inspector will fail me. So you just have to imagine what I'm doing. Now, the reason I want to hook up all my circuits before the sheetrock goes on is if there's a problem, I want to know where it is. So these, what I do here on my outlets, I make a pigtail off the black and off the white, and then later when my outlet goes on, all I have to do is I hook up to the pigtail. Okay, now do I have to have the pigtails for the outlet to work? No, I don't. I could just hook up the black side here with the 2 screws and the white side here. The only thing about that is I don't know if I'm going to get the continuity through my wires until after my sheetrock's all up and painted, and then if there's a problem, then I have to go and rip off all the sheetrock. So I'd rather know right now if there's any problem. Okay, so that's the reason I'm telling you why I hook up my wires together in the boxes and leave them wire nutted. And I'm also not just going to leave bare wires sticking out of my boxes, or any bare wires at all. They're going to be capped off with this wire nut in case that circuit, somebody flips the breaker and the circuit goes on during the sheetrock or whatever. If they're live, at least they're going to still be somewhat safe, okay? So now I want to talk about where my switches are, because all the switches is just where you interrupt the black wire. So I have a 3-wire going from the first switch to the second switch, because I want to represent where you can turn on those 2 lights using a 3-way switch, okay? So when I put these in the box, I just hook all my blacks together. The whites are going to be hooked together anyway. They're always going to be hooked together if it's a switch, if you do it like this, okay? And the grounds, you would normally twist them together and crimp them, but it's going to work with this wire nut, okay? So now that we have this on, let's test the other end of the circuit right here. We've already got that end. Let's go test this end. So I come here, see if we have the continuity up to this point. I just take my little probe, stick it in here, shut that down, stick it in here, and I have continuity up to this point, okay? So that's what I want. Now another thing is I was a little unclear on, at first, on these lights right here, because I thought the continuity would go through the light, but let's see if the continuity goes through the light. So I hook the black up to there, the white up to there, and look, there's no continuity in here. There's no continuity yet, okay? So I thought this was going to mess up my continuity test, but it didn't. So I'm going to hook the light up like I would normally have it hooked up when I'm roughing all this in, and it's not going to interrupt my, it's not going to mess up my continuity test. So we'll put this in here, and when I, just so you know, when I put these in the box, I electrical tape around these because I don't want these little things coming up and unlocking when I shove all these wires in. So there's the black one. Let's do the white one. Okay. There's the white one. And we could do our continuity test back over there, and it would still be the same thing. Okay? So, basically what I'm saying is, just on your home run, just hook it up like this, and then go test however many points you want, and you should still have your continuity. Okay? Now, we could also do the same thing, and we should do the same thing. We should check the ground also. No. We should check the ground also. So now we have to think of a way to put the black to the ground, okay? So here's what we'll do. We'll just put them all three together. I got her lucky. We'll just put all these three together and see if we can still get our continuity. Okay, because we're just using the black and the ground, but they're all three hooked together, so that doesn't matter, okay? So now let's come over here. And this time we're going black to ground. And I hope it works. And it did, okay? You see I got continuity there. So I want to make sure that my ground wire has continuity because that has to deal with the safety of my electrical system. And let's check it over here. Okay. That works too. And while I'm doing this, since I have all three of these tied together, I could even check white to ground. It's not like I really need to know, but we could check it. That's also working because we got all three tied together at the home run, okay? Let's check it at another point on the circuit. Not that we really need to because we've already tested it clear at the end. But let's just check it right here. So we'll go to the ground. And we got our continuity, okay? So the advantage to using the continuity test is you don't have to have the power on when you do that. You're not going to be shocking yourself. And another little thing I'm going to start doing, let me demonstrate this because I have a little story to tell you. Let's imagine this piece of wire was 250 feet long and it just came in the plastic wrapper from the store. Well, while I was wiring my house, I got a roll of wire that was defective and it didn't have a ground in it on one end I could see the ground, but the other end I didn't know it had a ground on it until I started pulling all the wires through my lights. And then I was in there, 5 feet, 10 feet, 25 feet, there was no ground. And so I called him and I said, take this back, I don't want it, it's gonna make me fail my inspection. But what I should have done is, and what I'm gonna start doing from now on every time I buy a roll of wire, and this is easy because when it comes in a roll, you could just take it like this. You could just do your black to black. And what I would do is I would take the wire nuts, these little wiggle levers with me. And then all I have to do is hook these up. Actually, I would need a 3. Let me get one of these 3 pieces off there. I have one in my bags. So I would take one of these, and these are really handy. Let me just show you up close what they are. Okay, so this is, if you're going to do a continuity test, these are the best little things to have, because you can stick your wires in there, and then you can see that that's where they touch the metal, and then even if you had live wires, it's going to be a lot safer to work on the live wires as opposed to just trying to unthread with a wire nut. So I really like these things. They're transparent, so you can see if your wires go all the way in. Okay, so if I'm at the store and I want to check the continuity, well, I could just put that one there. Let's do it like this. I could have done this with two twos, but we'll do it like that. Okay. So now I just need to know if these black wires are continuous. I take this here, put that guy in there, that guy in there. I know that black wire is good, okay? Now, I could do the same thing on the white wire, and on the ground wire I could check them separately, or I could just do it the easy way, and I could check 2 wires at once, which I've basically done in this continuity test that I'm showing you. Okay, so I just take my black and my white, and let's put this guy on here. We'll rob this from here. Check my black and my white, so if I can know two of them are good at once. I just put that there. And I know that white and the black are continuous, okay? So then I could check the same thing from, check the ground just using any two wires like that. Put them together there. And then check it here. And see, I'm like, why did I not get continuity? Well, you can see because I messed up with the wire. See, I got my probe on the white, but it needs to be on the black. So let's switch the wire nut over to the black. There we go. See that? Now I know the black and the ground have continuity. So I'm going to start doing this every time I buy a roll of wire. That way I know if there's a problem. And another thing, like, if you just know how to do the continuity test, even if you don't want to be an electrician, I'm not really an electrician. I have my apprentice license, but because I'm going to be a builder, and if I ever hire an electrician to do their work, and they're like, okay, we got the house roughed in, pay me, I could say, okay, I'll pay you after I do the continuity test, okay? Because if the continuity test isn't passing, then that means there's going to be severe problems, okay? So I'm going to cut the video now, and we're going to hook all this up and turn the lights on and do the voltage test and show you that if I pass the continuity test, then it's going to be a lot easier for me to pass my voltage test. So let me stop the video for a second. Okay, so now we're going to do our voltage test, and with my little cheapy voltage meter, it's also going to tell me if my circuit has the right amount of voltage. So I don't need batteries for the voltage test. I do have to have batteries for the continuity test, but this will work without batteries for the voltage test. So all it is, it's going to tell me if I have up to 12 volts, up to 24, up to 48, or up to 120. It's not going to tell me exactly like 118 volts or 122 volts, that would probably still be acceptable for your voltage reading on your circuit, but this is kind of like the dummy version, which is just, that's all I need. I don't need the fancy, $400, $500 voltmeter, just the little cheap dummy version, okay? So what I've done now is we're on the same circuit that we were using for our continuity test. And now, the only thing I've done is I take, so I have an outlet that I've got hooked up earlier. This is all hooked up in my panel box. I'll make another video and show you all my panel box and all that. But I'm live right now, going from there, following. Now I can take my voltage meter and I can test here. What the hell? So it doesn't matter if I put the black or the red, it doesn't matter which one I put it in, okay? But I don't want to be putting my voltage test from hot to ground or from neutral to ground, because this is on a GFCI breaker and it's going to trip the GFCI if I touch it in the ground. So I'm only concerned about the voltage across my hot and my neutral. So I just stick it in like this and stick this one in like this, and I got my 120. It's in yucky there. So the little testers, it's up to 120. It puts the red light on, it's a buzzing, and it says you have 120 volts. Okay, so I know that. Take those out. Now I'm going to plug in my circuit. Okay, I'm going to plug in my circuit here, Now, before you plug your circuit in, you have to go back and make sure that you don't have, because remember in our continuity test, how we had our black and our white together? If I plug that in right now, it's going to shoot sparks in my face and it's going to trip the breaker. So I go through and I make sure I don't have black and white connected anymore. Now it's separate because we're not checking for continuity. We're not using one wire to check two wires. So we take and we plug in our mocked up circuit right here. And we energize this. Okay, I'm just doing this for demonstration purposes. Don't feel like watching this video will make you competent to do this. You need to do your homework and check your information and don't just rely on what I'm doing. Alright, so now my circuit's live. Okay, let's go over and test my voltage over here on this end where we did our continuity test earlier. So this is all live, and this is, I feel okay doing this because these little, I have confidence in these little Wago wire nuts. I'll stick my probe in there. Stick my probe in there, and it tripped the breaker, okay? So let's go, it's either tripping the breaker or it tripped the GFCI. And you know what I did wrong? And you know how I told you about this earlier? And I said, when I was at the extension cord, I said, if you plug it into the ground, it's going to trip because it's on the GFCI. So that's what I did wrong. I wasn't noticing which one I stuck the probe in. So I'm going to disconnect this. JJ is going to follow me over to the GFCI breaker, and we're going to reactivate the GFCI breaker so we can continue with our test. So see, this is on the GFCI breaker, which since this is in a garage, they make me do the GFCI, so I just come and I reset it right there, and you can tell it's back on now because it has the little light came on, and I could also test the voltage here. See, look, I got 120 volts. Insignia, that's the closer the IE. So I got my 120, okay, which is what I want. So now let's plug this back in, and let's go back to our starting point. Okay, so we tripped our GFCI because I had accidentally put the black to the ground, and the GFCI doesn't like that, so we went and reset the GFCI. Now let's do black to white on our voltage test like we were talking about. Okay. So this time I do the black and the white. And there it is. That's my 120 volt. Okay. So I take these out. Let's go check at the other end of the circuit. Right here. So you can... And I'm going black to white, 120 volts. And it doesn't matter which color, if I put red to white or black to white, it doesn't matter with the little voltage tester, okay? See, now you see why I like these little Wago nuts? It's so easy to stick the probes in and take them out, and I can feel like I'm not going to get shocked. All right, so now I could take and I could do every single point. I could do every single point on this circuit again and test it. But why would I want to do that if I've already know I have the 120 volts? Unhook this first, and we're going to start plugging. We're going to start hooking up our. Our wires to our outlets and our lights and show you that they work. So first thing I'm going to do before I do anything else is I'm going to unplug this. Okay, Põe a pausa, J. Põe a stop, JJ. Saca tus dedos. Okay, we've done our continuity test on our circuit. We've done our voltage test on our circuit. Now we're going to plug it in and see if the lights work. So we just plug it in. And let's check out our circuit. Is it working? Well, the two bottom ones are on. We're going to shut the garage door here because that way you can see it better. So JJ said he's filming. He said only the two bottom ones are on. Well, he's right. Look, the two top ones are not on. How come the two top lights are not coming on? Well, because if you remember from our circuit, we'll show you that's the power. That would be our home run. That would be representing where it comes into the panel. Home run. Then from this point, it comes off, and I have an outlet right there, and I have an outlet right there. Okay? So those are going to be constantly on as long as the circuit's on. Now the top of our circuit up there, it's not coming on because supposedly that's a switch. So I'm going to turn the switch on and see if it works. Filma-me, gente. Estás cuidando dos dedos? So if this works on my three-way switch, then those top lights should come on. Did it work? It worked. And now I can turn the top lights on and off by either one of these switches. No, regresa aquí a donde estabas. Cuidado con el cable. I don't want him stepping in here because this is all live. So I can turn my lights off from either switch because it's a three-way switch. If you don't get a three-way switch, it's not going to work. I'm not going to tell you how to wire the three-way switches on because that's not the purpose of this video. I was just making a video to show the continuity test and show the voltage test, how I like to do it, okay? And so I'm going to leave these lights on. I want to talk to you a little bit about these work lights. So these are just the little temporary work lights. And you see how I got it wired in there? Because I'm leaving these little fancy 4-inch can lights. I'm leaving them wired in. And I'll show you what I've been doing. Like, for example, I have a little 4-inch can light. You see how I have that one's roughed in. You see it way up there, that transformer. So it has the two wires going in. But where I think, well, it would sure be nice to have a work light right here. JJ, prende el interruptor de allá. Because I've already these circuits are live. And so that I could just drop a work light wherever I want it. And then when I do my sheetrock, I can connect and unconnect that light really easy because see how I have the little way goes on? So I can disconnect those like that. And I got these. These are also just the work lights right here. And I've just put these ones with the bases on. And I could take them in and out of that box, cut my hole in my sheetrock, slap it back in. Okay. I got these ones over here. The little work lights, just so handy on those Wagos. And then I don't have to walk around with this and recharge it because I've already got my system wired up. So wherever I want to put a work light, I could just put a work light for my little closet down here that I could work on them and take them on and off as I want. So that's another reason why I like to have my circuits landed on my panel, and I can turn it on and off whenever I want. So when I'm working, if I need an outlet here or there, I could just throw an outlet in. None of this is live right now. It's all It might be live, but I got it wired. I got it wire nutted off in there, and the box is grounded. So that's another reason I'm working on my sub panel, still putting that together. But before I put any sheetrock on, I want all these circuits tested. Continuity test, voltage test, and then I want to put lights wherever I want. So it's taken me a lot longer to do this. And I'm also kind of wiring my switches in as I go. I got to put electrical tape on there because since these are live, I mean, it's still not the safest thing in the world, but it's going to work for me to put my sheetrock in. I would never hook these on and leave no electrical tape on there. If you want to be really safe, you could screw these in, and then when you go to put your sheetrock on, take the screws out, but that's just extra work for me. So now I got my switches on and they can stay like that. After I get my sheetrock on, I can just shove them back in the wall and do my sheetrock and paint it. So that's why I do it like that. So anyway, there's our little video. It went kind of long, but if you learned something, it's better than some of the other mind-numbing garbage you see on YouTube. They're not going to teach you anything. But there are way better electrical videos out there. Check out Electrician U. Check out Benjamin Soundstrom. Sparky channel. There's lots of... If you want to learn electricity, you're lucky because YouTube is a great resource. So I hope I've made my little contribution in some way. Do a little bit of giving back. I know I don't express myself the most eloquently, but I hope that helped. So I'll see you next time. I'll do a longer video next time, I promise.